Welcome to our full 10-minute adventure. Today, we're going on a journey from the surface we walk on all the way to the white-hot metal at the very center of our planet. We know a lot about the stars and distant galaxies, but what's inside our own home is still full of secrets. It's like a giant ball of mystery just waiting to be opened. In the 1960s, while some people were racing to the moon, scientists were racing to see who could dig the deepest hole into the ground. A race to inner space. First came Project Mahole. Scientists used a massive ship to drill into the ocean floor because the Earth's skin is much thinner there than under the continents. They successfully pulled up the first ever rock samples from the deep ocean floor. It was a scientific triumph that proved we could touch the deep crust. Next, the Soviet Union tried something even bigger in a snowy place called the Kola Peninsula. They wanted to dig the deepest hole in history. The team dug for 24 years. They reached a record depth of 12,262 meters in 1989. It remains the deepest man-made point on the planet today. That is deeper than Mount Everest is tall. If you dropped a rock into it, it would take nearly a minute to hit the bottom. Imagine a hole that big. At 6 kilometers down, they found something impossible. Tiny fossils of organisms from 2 billion years ago. Even in the dark, hot rock, life found a way. In Germany, the KTB project also pulled up amazing core samples from 9 kilometers deep. They were surprised to find the rocks were much hotter and more fractured than anyone thought. Today, Japan's ship Chikyu uses advanced technology to study fault lines and earthquakes, helping us understand how our planet moves and breathes. Now that we know how we tried to dig, let's look at the 4 main layers of the Earth. Each one is different and very important. First is the crust. It's the thin skin we live on. It's mostly solid rock and is only about 70 kilometers thick under the continents. That's very thin. Under the oceans, the crust is even thinner, just 5 kilometers. That's why scientists often try to drill there to reach the deeper layers. Below the crust is the mantle. It's the largest layer. It's solid rock, but it's so hot that it flows very slowly, like thick honey over millions of years. If the Earth were a giant pie, the mantle would be 84% of it. The crust we walk on is only a tiny 1% sliver of the whole planet. Isn't that wild? Then we have the outer core. This isn't rock. It's a vast ocean of liquid iron and nickel. It is as hot as the surface of the sun. Finally, at the very center is the inner core. Even though it's super hot, it's a solid ball of metal because the weight of the entire world is crushing it. Earth isn't the only one with a heart. Let's compare our core to our neighbors in space, like the Moon, Mercury, and Venus. Each one is unique. The Moon's core is tiny and cold. It stopped beating billions of years ago, which is why the Moon doesn't have a magnetic shield like we do. Mercury is almost all core. It's like a giant iron ball with only a thin skin of rock on top. It's the iron planet of our solar system. Venus has a core almost identical to ours, but its heart is stagnant and still. Because it doesn't spin, Venus has no magnetic field to protect it. This chart shows the difference. Mercury is nearly all heart, while our Moon has almost none. Earth is right in the middle, and that's why it works so well. Our liquid core creates a powerful magnetic shield. It's like Earth has a giant invisible magnet protecting everyone on the surface from the sun. This shield stops dangerous particles from the sun. Without it, the sun's wind would blow away our atmosphere and we wouldn't be able to live here. Scientists know the outer core is liquid because of seismic waves. Some waves can pass through anything, but others are blocked by liquid metal. But this engine can be unpredictable. Every few 100,000 years, the poles flip. The last time this happened was 780,000 years ago. We are arguably overdue. Earth is like a giant machine. The spinning core is the engine that keeps our planet alive and safe in the cold void of space. It's truly amazing. Now, let's imagine the ultimate shortcut. A tunnel from one side of the Earth to the other. What would happen if you actually jumped in? Classic math says 42 minutes, but because Earth's center is so dense, you would reach the other side in just 38 minutes. You'd be moving so fast. At your fastest, you would be traveling 8 kilometers every second. That is faster than any jet plane ever built. It's as fast as a satellite in orbit. But at the exact center, something amazing happens. you would actually float. Gravity pulls you from every direction at once, leaving you weightless. Once you pass the center, gravity starts pulling you back. It becomes your brakes, slowing you down as you move toward the surface on the other side. If you didn't grab onto anything at the top, you'd fall back down again. You'd become a human pendulum, swinging through the Earth forever. Imagine that. Why can't we build it? No known material can survive the 6,000-degree heat and the unimaginable pressure found at the planet's heart. It is a forbidden zone. The heat and pressure would crush any building material we have today. But even if we can't build it, thinking about the physics is a great way to learn. Earth's core is protected by miles of rock, and that's a good thing. It keeps our planet warm, safe, and shielded from the silent void of space. One day, we might find new ways to peek inside and learn even more. But for now, the heart of our world remains our most amazing secret. Let's recap. Humans dug 12 kilometers. Earth has 4 layers, Mercury is mostly core, and a gravity fall takes 38 minutes. You're now a planetary expert. We've explored the deepest holes and the hottest cores in our 10-minute journey. Earth still has so many mysteries for you to discover. See you next time. Thanks for joining me on this odyssey into the heart of our world. Don't forget to subscribe and turn on notifications for more simple science adventures. Keep asking big questions about our world. The center of the Earth might be far away, but the wonders of science are always right under your feet. This project was inspired by humanity's endless curiosity. Keep exploring, keep learning, and keep looking deeper into everything you see around you. The end. See you on our next adventure. Keep curious. Goodbye.